we are going to linearize the function x cubed minus x squared plus 3 at the a value, -2. And this right here just means that we are going to find the equation of the line tangent to the curve at this a value. And we do have a very nice formula, and let me put that down for you guys. L of x, meaning the linearization of this function at this a value. And this is just going to be the point slope form of the line, but in this form. We will first have the value of the function at this a value, and then we will just have to add the derivative of it at that a value, and then we multiply by x minus a. Again, you see, this is the x minus x1, and this is the slope, and then this is the y, and technically we have the minus y1, but we put the y1 to the other side, and this right here is exactly the linearization. And the process is we are going to linearize this. That's what it's called. All right, so here we go. Let's go ahead and get f of a first, which is f of -2. So that's going to be -2 to the third power minus -2 square and then plus 3. That's -8 minus 4 is -12 and then plus 3 we have -9. Done. Next, we need the derivative. So look at this and then differentiate that. We get f prime of x. That's equal to, use the power rule, we get 3x squared and then minus 2x. And then we plug in the a value. So we have f prime of -2, and this is 3 times -2 squared minus 2 times -2. Check this out. This is 4, and that's 12, and 12 plus 4 is 12 plus 4 is why is this so hard? 16, yeah. Anyway, 16. And now we have all the ingredients, we can just go ahead and put that down, right? So, ladies and gentlemen, the linearization is going to be f of a, which is -9, and then we just add the derivative, which is 16, and then multiply by x minus the a value, which is -2. So let me just put that down right here real quick. Cool, and then perhaps we'll just multiply this out and then combine terms. So ladies and gentlemen, linearization is going to be 16x. And then this times that is positive 32. Minus 9, we get plus 23. And that's it. This is the linearization for that.